So three-dimensional drawing is possible in processing, and 3D has a lot of capabilities that you just can't do in 2D drawing, of course, as you probably know if you've ever played a computer game. So here we have an example of how to draw a 3D box. Basically, we say size, we give a size value, and then we say P3D, which gives us the 3D renderer instead of the two-dimensional renderer. Then we say stroke weight 6, we're moving to the middle, and we're rotating. Now this is a three-dimensional thing. If we don't rotate, we'll just see the box from the closest face, and it'll just look like a square. So once we rotate, we'll see the box from the side, and we draw the box there. So let's have a look at simple cube. Here we go. Simple cube. Very simple example. Basically pretty close to what I just showed you. This one's got the loops, so you'll see the drawing as it moves around. We've said background 255. Said translate width to move to the middle. And then we're rotating by frame count times a certain value, so that we just keep an eye on the number of frames, and we're drawing a box. If I don't do the no fill, we get a box that we can't see through. We can still see it's a box. And we can change the size of the box here, obviously. Great. Okay, simple cube 2. This is the simplified version you can have a look at. It's just the drawing commands to draw the box. Now this one's the drawing commands to draw the box rotating. So that's pretty similar to the previous example. A bit faster though. There we go. So you'll notice there was no lighting for those 3D boxes. They looked like they were drawn in a computer. You couldn't. They didn't give a realistic look for three-dimensional stuff. So lighting is very important. There's lots of different sources of light in a 3D space. There's ambient light, which sets the reflective color of a shape. So basically, when light falls onto an object, certain colors are absorbed and certain colors are reflected. The classic example is a leaf of a tree absorbs every color except green, which is why the green light reflects and we see the leaves as green. The rest of the light is absorbed into the leaf, and photosynthesis occurs to generate the energy that the tree lives off. Ambient light here sets the ambient directionless light. So some light in any scene is light from, say, the sun or a lamp. It's light that is direct. And some other light is reflected off the surface. So if you're sitting in the shade, you're still not in complete darkness because there's light around that is being reflected off other surfaces in the environment. And that's ambient light. Light specular sets the color of the directional light. So that sets the color of the sun, for instance. And you can also use HSV terms here. So let's have a look at an example of that. So this is a simple sphere. We have size, background, no stroke, you know all about those already. Now these are new. Sphere detail, that sets how many triangles are used for the sphere, or polygons. This is the ambient light that the ambient color of the sphere, as we discussed, in red, green, and blue. The ambient light in red, green, and blue, and the specular light, red, green, and blue. So this is a reddish white light. And there's the command for the directional light and the shininess. So let's have a look at what we can do. That looks like a pretty impressive sphere. So we can change this to, say, 100 to make it nice and matte. Doesn't look very matte. Get it right down to a very low value. Okay, you see the surface, the specular surface doesn't changes quite significantly. So here it is with the very shiny version. We can change this to be mainly, say, green. Lower this and change the color of the sphere. Blue, sorry. Whoops. It's a mistake. Oh, my green. There, that's got a bit of a green hue. But don't forget the other light is red colored, so we've got some other light here. So why don't we make the light that is reflecting nice and strong in the green. So that's the ambient light, which is why you see the other side being quite strongly green, and the specular light is mainly white with a bit of a red hue. So let's make the specular light strongly blue and see what happens. So you can see there, that's a bluer light. There we go. The directional light is what's controlling the blue side, but we've also got this specularity. Okay. So directional light points the directional light at the scene. So you've got red, green, blue, and X, Y, Z. So that's the color of the light and the location of the light. The shininess sets the amount of gloss on a shape, and you can just call lights to automatically provide basic lighting if you just want to see the things with some light. If you don't have any lighting, things will kind of look two-dimensional, and that's a bit weird. Now, as with 2D, you can draw your own custom shapes using vertex. So positive Z numbers are towards you, out of the screen. So here we've got begin shape, vertex, 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 end shape. And notice we've now got 3 values, not 2. It's not X, Y, it's X, Y, Z. So we can have a quick look at one of these. Here's a vertex example. So this is just a straight shape. There we go. But notice we can't really understand it unless we are able to rotate it a bit. So let's have a look at this shape being rotated. So we've got control with the mouse, and we can see that this shape has a bit of a convex angle in the middle of it. Doesn't really work well unless we have some kind of color to it or image. This is a texture. This is pretty critical. So we've taken that image and we've placed that onto that shape. So you can see image is loaded here, texture mode normal, and then pretty much everything's the same. We've got our 4 vertexes there, except we say in the shape texture img. So you can use that for a lot of things. This is a very powerful tool. You can use that to do all types of interesting things. So hopefully you now understand basic bitmap image processing concepts. You can understand simple 3D graphics in processing. And next week we're going to work with video. So video is like 2D pixels with images, but over time. So lots and lots of calculations happening very fast. So that's going to be kind of fun. All right, thank you very much.